This week, Josh Bressers joins us to discuss open source supply chain security and some about the state of CVEs. Stay tuned. Below the Surface, coming up next. Welcome to Below the Surface. It's episode number 49, being recorded on Wednesday, April 30th, 2025. I'm your host, Paul Asadorian. I am joined today by Mr. Josh Bressers. Josh, welcome.
I'm excited to be here. Thanks for having me, Paul.
Josh, what is so you work for Anchor, right?
Yep,
Give us a little bit about yourself.
Yeah. So, my story is long, as you and I are of a certain age, we'll say. And I've been doing this open source thing for forever. Like, it's been 20 plus years. I spent a couple of years at a Linux startup called Progeny Linux Systems. I was at Red Hat for a decade. I was at Elastic for a while. Now I'm at Anchor. And it's a fun place. We do, you might call it like supply chain security, SBOM management, vulnerability scanning, kind of all that. And we have two open source projects called SIFT and GRIPE. SIFT is an SBOM scanner. GRIPE can scan SBOMs for vulnerabilities and like other stuff too, but SBOMs are the best for that. And then we have an enterprise product called Anchor Enterprise, and it basically builds on top of SIFT and GRIPE, where it gives you, the automated scanning, storing of all this stuff, policy enforcement, the usual enterprisey things people like to see. Whereas SIFT and GRIPE are just very like, run these commands and get a thing out, and then figure out what to do with the thing.
Right, yeah.
But they're great tools, and they're really easy to use.
That's awesome.
It's a lot of fun.
And you also host the Open Source Security Podcast and the Hacker History Podcast.
I do. I stay busy.
It's awesome.
But yeah, so open source security is a lot of fun. That's where I recently changed formats. It used to be like the two dudes talking format, and now I do a lot of interviews, and I try to like ferret out really niche open source security people. I don't have any sponsors, so I don't care, which is great.
Right.
So I get to go look for like the obscure stuff that I want to learn about. And then you meet a lot of cool people on the way, which is fun.
Nice.
And then hacker history is kind of the same deal where, I find old school folks, you were on Hacker History, you told your story, and it's just tell me your hacker story, and then people tell their story for as long as I let them.
This is what Josh and I do. We just appear on each other's podcasts. I think this might complete the entire circle where we've appeared on all of each other's podcasts. Yes,
I think it does.
It has.
I think it does.
That's really funny. I just want to read a quick announcement before we dive into the topics. As always, Below the Surface listeners can learn more about Eclipsium by going to eclipsium.com/go. We've got some stuff there, including the ultimate guide to supply chain security, a webinar called Unraveling Digital Supply Chain Threats and Risk, a paper on the relationship between ransomware and the supply chain, and a customer case study with DigitalOcean. Of course, you can sign up for a demo, and all that at eclipsium.com/go. Josh, I wanted to dig into open source components, right?
Yeah.
Because that relates a lot to what you do as well as what we do here at Eclipsium. I'm finding that open source components are in everything, whether it's the entire operating system or PC servers, laptops. There's a component.
Yeah.
Oh, look, like you liked Linux and computers so much that we put Linux and computers inside your computer. So how do we work with the supply chain on these, right? This is the crux of the issue for us at Eclipsium.
Yeah.
And this is an attack surface that a lot of people just aren't paying that much attention to. The fact that you buy these things, you put them in production, and by the way, under the covers, there's open source somewhere in multiple places.
So I like to rewind the clock a little bit, where I feel like probably 5 or maybe 7 years ago, give or take, I remember going and talking to customers, talking at conferences, things like that. And I'd ask people, how many of you think you're running open source? And like half the people would maybe raise their hands like, nope, it's all of you. Guaranteed it's somewhere in your infrastructure. You might not know it, but it's there. And I feel like that scale has tipped where it got snuck in the back door, right? Like open source is just so useful. The price is right. It's easy to get. I don't know, Paul, if you've ever been involved trying to like procure software, but it takes like months and months, right? And back and forth, and you got to sign contracts and MSA agreements, and the lawyers argue, and it's just a nightmare versus pip install, requests. There, done. I've got my software. And so just open source took over the world. And it's really funny because I'll never forget, I graduated college in 2001. And when I got out of college, my first job was at this company that wrote life insurance software. And I remember I was, of course, like, the bright-eyed open source,
Mm-hmm.
youngster. And everything was, oh, we can solve that with open source. We can
As
use
with
Linux
I,
for this,
yep. A
And
lot
they
of
were like,
pushback back
holy
then.
crap. Yeah, shut up. Like, stop talking, nerd.
Yeah.
And it was funny because, like, I remember my boss was like, you're a smart kid. Like, quit mess. Like, this open source stuff is a dead end. Like, no, there's no future in
Yeah.
this. And I'm like, and honestly, and at that time, it was not like a sure win. We didn't know,
Yeah.
as a youngster, I was like, oh, of course it's going to win, like, because it's the right thing. But we didn't know. I mean, it was crazy. And now it's absolutely everywhere. It's in absolutely everything. It doesn't matter who you are or what you do. There's open source, like 100%. It's wild.
Yeah. And one of the areas that I came across where there's some heavy open source usage is BMCs. And I think the reason what we're getting down to is why folks want to use open source is because they don't want to reinvent the wheel. So
Yeah.
you get this largely ARM based chips that run your BMC. Linux runs great on ARM. Someone created OpenBMC. I don't pretend to know the history behind it, right? And a lot of manufacturers adopted OpenBMC
Yeah.
and tune and customize it to their needs. And so, like I said, now you've got all these servers and you're running Linux on all your servers because likely it's
Yeah.
a BMC from ASPEED that is an ARM chip that's running Linux, likely with an older kernel, right? And
Oh,
older
you know it.
software on it. Um, so what is your take, Josh, on why that happens? I gave the BMC case, but there's a lot of embedded systems that run largely older software that present now supply chain vulnerabilities.
Yeah. Yeah. I mean, it's easy to get, right? I mean, uh, uh, you and I remember the embedded days back in like the early 2000s, right? Like it was bananas. It
Right.
was impossible to even find software for a lot of this stuff. And anyone working on it, it was often your OEMs and your ODM type operations were very expensive. It was very hard to get any custom anything done.
Mm-hmm.
I mean, it was just wild. And now it's the bar has come down so low. It's so easy. And honestly, the margins on this stuff, I mean, I'm sure you're familiar with this, Paul. Like a lot of this gear, the days are gone where the margins are thousands of dollars. I mean, I think if you have a
Yeah.
margin of a couple dollars, you're probably doing pretty good, honestly.
Mm-hmm.
And that's the thing. Like, if your margin is $2, that's a huge difference between, build versus buy in the context of software, where if you can get something for free that basically does the job, you're going to totally do it. I mean,
Right.
this is even true of just like software in general, of the
Yeah. And
cloud
why
and
spend resources updating it if it's
right.
working? Yeah.
Well, that too. I mean, that's a whole
Mm-hmm.
other conversation. But I mean,
Mm-hmm.
just starting the project,
Mm-hmm.
right? Like, if you're going to start a brand new project, be it something for your company, some personal project, whatever, you're going to go to the open source well, and you're going to start pulling up buckets of water because you're going to find stuff that does exactly what you need, or it does it good enough that you don't
Yeah.
have to worry about it. I mean, remember when we had to buy a web server? Like,
Right.
that's loony to even
It's
think
loony.
about
Yeah.
now.
Right. Right. Yeah. And it comes with a lot of responsibility once you do
Well,
that.
it
Right.
should.
It's good. Right. Back to oftentimes it doesn't get updated.
I mean, and this is human nature, I think.
Mm.
I will not blame all software people for being lazy bums, even though the best ones are. But like one of my favorite examples is home ownership, right? If you own a house, it is like a constant effort to keep your house maintained, to keep it updated. You need a new roof. You got to fix the plumbing. You got to fix the door, whatever. There's a million things.
Right.
And there are people that spend the money to keep their house in really nice shape. And then there are also people who just run their house into the ground. And by the time they get rid of it, like it is a heap of garbage and it is
Right.
an enormous effort to fix. Every house I've ever bought has been an enormous effort to fix. I mean, the house I'm in right now, the foundation was literally shot and I had to replace the entire foundation.
Oh my
It's
God.
a crazy story. 100-year-old house. Like it was an adventure. Never
Mhm.
buy a house that needs a new foundation, by the way, for
Right.
anyone. But, but anyway, so you get all this software, and then it's easy to say, oh, just update your dependencies, right? And that's not how it works often. I mean, ignoring the ability to update things, because when we're talking about embedded systems, especially, like you can't just update an embedded system, right? It's often impossible. And that's assuming you can even get to the embedded system, because if it's, inside of a machine, you're not touching that. And if it's working, why are you going to touch it, right? I mean, and I think that's kind of what got us into this weird mess we feel like we're in right now, is there's all this software and it's been working. And historically, we didn't worry about it because it was just running in a machine and it was hooked up to, some dumb terminals sitting over there in the operator's little booth, and everything was great. And then we got the great idea, like let's hook it up to the internet. And now all the bad guys are like, oh, holy crap, they hooked it all up to the internet. And now it feels like an emergency, right? And it's like this horrible thing that's going on where everyone's running old software. We don't know what to do with it, and everything's a mess.
I think what you're hinting at too, and reminding me of, is once you build a system and it's working, and those of us that worked with open source and Linux for a long time know, once you update one thing, now you're in what we call potentially dependency hell.
Yeah.
Right.
Yeah.
Now the other component needs to be updated, but then that component relies on something else that also needs to be, and this is what we call dependency hell. And I think that there's a large cost to sort that out, that many companies are like, it's end of life, or we're not going to issue an update for it because is too much resource intensive to do all of those dependent. Once I update the kernel, now I got to recompile all my modules. And oh, by the way, one of my modules is a binary blob that I don't have the source code to. So then now what do I do? Right.
Yeah. Yeah. So one of my favorite stories is that life insurance software company I worked for right out of college. They had a binary blob that no one knew where it came from. No one knew exactly what it did, but they knew if they took it away, everything broke.
Worked.
And it's like, this is the best. And I figured out eventually, it was just zlib is all it was. So it wasn't like that big of a deal. Well, it was a big deal because we still could get rid of it. But yeah, it was really funny. But anyway, okay. So you talk about dependency hell and updating things. And it's funny because actually before we hit record, Paul and I were talking about how like 10 years ago, if you ran Linux on your desktop, which we both do, anytime you updated anything, like it all broke.
Yeah.
And these days, like I mean, I upgraded my desk computer to Fedora 42 last night, and it was flawless. Like you wouldn't even know, other than the background changing, you'd have no idea that anything was different. However, that is easy to say in certain contexts, but there's still a lot of things that you just don't update the software. And like if you're running a cloud, any sort of cloud instance of anything, you're probably running old stuff. Now, the other piece of that, I think, is no one is buying security today on the market, right? When you're like there's the old saying in product management, I can sell a feature, I can't sell half of two features, right? No one is selling security today because, quite frankly, there's just no market there. The market is for features, for solving problems you have. Now, I'm hopeful that starts to change. I think things like software bills of material will help a little bit, because now, cloud service or not, if you have to give me the list of stuff and I look at the list of stuff and I'm like, holy crap, this is older than me, now I know there's a problem, right? Versus if I want features, that's what I want. I can see that people get promoted for features. Everyone likes features. So I think there's kind of that capitalist push away from updating your stuff right now.
Yeah. It's interesting too, Josh. I think about vulnerability age as an indicator that you're in a tough spot. The older the vulnerabilities are on whatever component or device that you have, likely the more risk you're going to have running that software. And it's interesting. And I see like these little examples that make me kind of rethink things. I think it was Quark's Lab was like, oh, we looked at this component. It was running this older component. I think it was PHP. And they fixed this bug or fixed this vulnerability, but they didn't really fix it. And what we found was we could go and exploit it. And the bug was like 5 years old, right? So it's making me rethink how we do analysis of our security posture and how we make decisions on remediation. I don't believe we can sit here today and go, well, if it's critical, I'm going to fix it. Otherwise, I'm going to get to it when I get to it. I think we have to be more proactive at keeping our software updated. But that brings it down back to our core discussion here in open source software and components, devices, and products, right? Sometimes you can't because the vendor has to do it, right? Pick any VPN or firewall appliance. My hands are tied, right? And that's a problem.
I mean, you even have this problem in the open source ecosystem. So there's this thing we call transitive dependencies, where I depend on package A And then package A depends on packages B and C. So let's say there's a vulnerability in package C. I might not be, there's probably nothing I can do about that because package A is what actually has to like upgrade package C beneath me, right? You can imagine there's layers and layers and layers. And so you can have a vulnerability like 20 layers deep that you just feasibly can't even do anything about until everything along that chain gets that update. And I mean, that's
Right.
one of the challenges we have is sometimes we can't do anything. And I mean, I've seen more than once where there's something buried way down in the dependency tree that has some vulnerability that you might even be, vulnerable to. That's like an actual thing that's going to harm your product. And the new version is a breaking change. And the open source developer is like, I'm busy and I don't have time to do this right now. And maybe I'll get to it in a month. And in that case, you're
Right.
like, what do I do?
And those open source issues trickle into commercial products because they're using open source
Yes.
and now they're stuck. And I mean, what's the answer? So can we compel vendors to provide an SBOM? Is that our first step in this process to becoming more resilient, is just knowing what's inside and having the vendor publish it?
Yeah, I mean, I think that's a big part of the story. This is where, if you look in the European Union, they have the CRA, the Cyber
Yeah.
Resiliency Act. It's in progress. We'll call it. It's going to be years before we see this like actually rolled out and enforced. But they're saying things like you have to have an SBOM. They're not saying exactly what that means. They're not saying who you have to give it to. There's a lot of squishiness in that regard. But they're saying
Sure.
things like, yes, you need an SBOM. You need to support your software, right? This is not like we're just going to kick it out into the world and like YOLO, good luck with that.
Mm-hmm.
They're saying you have to deal with vulnerabilities. Like you can't just ignore them and say, yeah, whatever, it probably doesn't matter. Like, no, you have to actually understand what that means. And I mean, this is a thing like in the US, there is well defined case law that when you are like the final manufacturer of a thing, you
Yes.
take all these components in, like it is your responsibility. It doesn't matter if someone, 6 layers up gave you a bum part. It is
Yeah.
your
I think
responsibility.
Josh Corman talked about that a couple of years ago. It was something
Yeah.
about wooden tires on,
Yes.
right? And there's that's the basis, the premise of the case law
Yep.
goes all the way back to when we had wooden tires.
That's right. Because
Yeah.
I think it was like Oldsmobile tried to
Oldsmobile or
blame the
something. Yeah.
tire manufacturer, and the
Right.
courts were like, absolutely not.
Yeah.
Like you are responsible.
Right.
Yeah, yeah. But and here's the thing. In software, we have mostly skirted any sort of legal liability almost
Yeah.
every way you can imagine. And the problem is, so actually I've talked to Josh and there's Wendy CK is what she goes by, but
Okay.
she's given many talks on the liability aspect. And the fundamental problem is when you go to court, you have to show like monetary damages or like physical damage of some sort. And generally
Mm-hmm.
speaking, in software, it's very hard to prove that, which is why we've
Mm.
struggled up to this
Oh,
point
that's
to
interesting. Right.
enforce any of this. And now this is why like the regulations just need to change. That's what needs to happen. And Europe is doing that.
Mm.
So we're going to see what happens. Now, at the same time, though, right? Like anyone who deals with regulators, that regulation can also end up being meaningless, where it gets watered down to
Correct.
the point that it actually doesn't make a difference. So I'm hopeful, but we'll see.
Yeah, and it's a hard problem because back to VPN appliances. If we're really being proactive, we're not waiting until someone discovers malware on an incident response, traces that back to a vulnerability, and goes, "Oh, by the way, vendor, you have something that you need to fix because we saw malware." In that case, we see vendors, whether it's open source or commercial, going, "Oh yeah, we'll fix that." But how do we apply more pressure to get this done before it's being exploited? Because now it's too late. Right now we're in this horrible
Yeah.
situation that we're in where we're waiting for a patch from the vendor, but attackers are having a field day.
Yeah, for sure. For sure. I mean, look, it's easy to say vote with your wallet, which some
Yeah.
of us do. I mean, if
Some
you're,
companies are doing it. I interviewed a CISO that
yeah,
was doing exactly that. He's like, look, I won't tell you who the vendor is, but we're switching from vendor A to vendor B, and that switch is based on security. I'm like, really? Nothing else? He's like, nope, it's based on security. I'm like, well, that's pretty awesome.
I mean, that's great. And I hope there are enough organizations that can do that to maybe, push things along. It I don't know if there are. I mean, only time will tell. I suspect in the consumer marketplace, it's kind of a tire fire already because I mean, goodness knows, most consumers buy like literal garbage on a
Yes.
regular basis. So
Well, that's a different
yeah,
ball of
that's a
wax
tough one.
entirely,
That's
right?
tough
That's
for
a whole
sure.
different podcast. I feel like is the consumer aspect
Oh my
is
goodness.
bad. We still
For
have
sure.
Android devices out there that get malware, and we still don't know where it comes from.
Yeah.
That irks me. That keeps me up at night. It's one of the
Yeah.
things, right?
Yeah. Well, it's
Um,
because the intern flashing all those phones was
so-
browsing Reddit on that computer.
yeah,
You know?
or someone dropped off a bag of money to whoever's putting
Yeah,
the
that
software in
too.
or something, right?
For sure. For sure.
Um, I want to dig into some of the tools, right? Because I don't want to talk about the challenges that we have in bringing devices to market
Yeah.
in a
Yeah.
secure manner without talking about, well, what do we have for tools to help you build more resilient and secure products? And if you're
Yeah.
building something on open source, and I know you folks make freely available SIFT and GRIPE, but there's other tools, SCA, very similar space, right, to
Yep.
help developer teams understand the problems and fix them before it comes to market. I feel like this is a step that is missing or ignored in a lot of software hardware manufacturers.
Yeah, for sure. Okay, so I'm going to break the problem into two pieces right off the bat. So we have the instance of, let's say we're using a well-defined ecosystem. This is something like NPM or,
Yep.
Python has PyPy. If you got like Ruby
Yocto,
gems,
I
whatever.
saw Yocto recently
Yes.
as a build system, right?
Yes, yes. And Yocto is going to come up because they're actually like the gold standard for how to do
Okay.
this stuff with
Okay.
C and C++. Okay.
Mm.
And then on the other side, you have what we'll call like more of a copy and paste problem of open source. And the embedded world has this all the time. I mean, you've talked about this on like Paul's Security Weekly recently. Well, like the ESP32 Bluetooth thing, you actually came on my show, which isn't out yet. But
Sure.
I was asking you questions about that, right? Where if you copy and paste code, and this is actually where the old SCA vendors, like your Black Ducks,
Yes.
kind of came to be,
Which
was
is
because
I think it's Synopsys now, right?
yes,
Yeah.
Synopsys, they bought them, and like way back in the day, there were lots of companies that would say things like, no open source. We forbid you from using open source software.
Yeah.
So developers would just copy and paste source code into stuff because they're like, screw this. Like I want this code.
Yeah.
And so those old SCAs were really about like, we're going to analyze your source code and we're going to look for developers that copy and pasted open source into your stuff. And I mean, they found it because it was freaking everywhere,
Right.
And that problem is really hard to solve. And those tools are really expensive and their databases, quite frankly, can't even keep up. There's so much open source now.
It's hard just to keep up with. You're using this version of open source software
Yes.
versus what you're talking about is I looked at your source code and it's this much similar to existing open source code. Therefore, you have code. Yeah, I can see that being complicated.
Well, let's kind of ignore that problem for now because it's too hard. and look, the reality is in almost every organization, you're allowed to use open source. There's no good reason to be copying, pasting code like the good old days. Like use your packaging ecosystems. And so that's kind of step one.
Right.
Is use the tools available to you that help you download and use things. Like I'll pick on like Arduino is one of them. Like you don't have to download crap for Arduino anymore. They have like a nice built-in, let me manage your libraries for you, right? Lots of tools have this, lots of ecosystems have this. And the real advantage to using some of these tools is when you download a package, the metadata of what you've downloaded ends up getting stored somewhere on disk. So you can look later and say, I have this package in this version that I downloaded. You might be able to even say, I downloaded it from this location because goodness knows we've seen instances where a certain mirror or repo or whatever gets backdoored. And that's like a whole other problem as well. But like step one is just use these ecosystems. They exist for a reason. Now, that's easy to say, but there's things like C and C++. There's not a great ecosystem in the C and C++ world. And this is actually where Yocto does a really nice job. They have incredibly detailed SBOMs they release. And we should clarify. Yocto is like what is it? It's like an embedded Linux distribution, right?
I'll call it like a build framework. Is it a build framework?
I mean, sure. And it has Linuxes in there.
Yeah, yeah. Because I've worked with OpenBMC. In OpenBMC, if you want to build that on your own, you use Yocto to build that. And so I actually built an OpenBMC image. It used Yocto, and I'm like, this is never going to work, right? Because it goes through and it does all the things that in previous times we had to do by hand, building your tool chain, cross-compiling, because you're not, if you're on x86, it's cross-compiling for ARM, I think is the platform I built for. And it actually worked. And I was like, that's kind of amazing.
Yeah, it's really cool. It's really, really cool. And what they've done is they've instrumented these tools to pay attention to what's happening during the build. And like C and C++ are a great example where you might have like a directory with 50 .c files in it, but if you're only using one function, it's only going to use that one function from that one file. It's not going to
Right,
worry
right.
about any of that other stuff. And so this is where they do such a good job of creating these amazing SBOMs. But there's a lot of manual intervention. Like if you add a C library, you have to manually tell it, I've added this C library and this is what it
Hmm.
is. And then it will include it in those SBOMs. But it's not just like as easy as whatever, just figure it out, nerds.
Oh, I see.
Yeah, but they do such a good job in that regard. However, so all that together, like C and C++, not as solved as I wish it was. And then there's also the issue, which I'm sure you're familiar with, Paul, of like I built my binary. I've now stripped out all the debug symbols. I've stripped out all of the useful information, and there is like nothing in this I can use to my
Hmm.
advantage to figure out what it is. And so it's
Right.
really hard to identify binaries sometimes.
Yeah, binaries are it's hard. I mean, then you're basically either decompiling or disassembling.
Yeah.
And there's lots of vendors, ourselves included, working on that problem to understand from a supply chain perspective, what is this binary? What does it contain? Does it have vulnerabilities? Can I look for those vulnerabilities?
Yeah. Yeah. And that's so hard. That's so hard.
Yeah.
However,
It's
if
fun
you're
though.
trying,
I tell you, it's an awesome challenge.
oh yeah,
Yeah.
it is for sure. But if you're trying to be a good steward in this regard and you're trying to build product and you're trying to do the work in a way that we'll say is like as secure as can be, this is where you use something like Yocto and you make sure that the SBOMs being generated have the things you're including, right? As a good steward. Now, let's say you're more on the, we'll say user side where you've got, Python and Ruby and Go
Hmm.
and Rust
Hmm.
and whatever. You can be a little more lazy in those environments because what these ecosystems have been doing is they've been including a ton of really good information like metadata as you install packages. So like if I install a Python package, it stores the information like the version, the name of
Hmm.
it, all kinds of details. Like that's kept on disk, and that's a thing we can go look at. And like this is what SIFT does. Like SIFT, the SBOM scanner, like just digs around and looks for like JSON lock files. It looks for the
Hmm.
Python. Python doesn't have lock. Well, Python's
Well,
complicated because there's
requirements
requirements that
TXT.
text,
Yeah.
but now there's UV and there's poetry that also do
Poetry. Yeah. Yeah.
right.
Poetry.
So
Right.
it's like
Right. Right.
this
Yeah.
is weird, but whatever.
Hmm.
However, I'm going to give the Go folks and the Rust folks like the gold star here because what they've actually done is when you build binaries with Go and Rust, they leave a ton of metadata in those binaries that talk about like this is the dependency we used and these are
Hmm.
the parts of the dependency we compiled in because like
Oh,
Go
that's
and Rust
interesting.
are compilers, they will only compile in the code they need. And so
Hmm.
they are creating these incredibly data rich binaries. Of course, they're gigantic binaries, like you're
Sure.
not running them on an embedded device.
Yeah. Yeah.
But from the perspective of like supply chain security, the things they are including it's so valuable and it's so easy to just extract these important details and then you know what you have. And this also, if you're trying to be a good steward here, it's a lot easier to just run like an SBOM scanner and be like, whatever, we're done because all the metadata, because you're already using a packaging ecosystem, like it's all there. It's the hard work is done for you. You just
Right. But
run a tool, get an SBOM.
the next step segues us nicely into discussion about vulnerabilities in CVE because once I have an SBOM is a
Yeah.
manifest.
Yeah.
It's not telling you, well, that package is vulnerable to this and has this CVE, right? Is that
That's right.
Vexed is the standard that helps us with that? But there's multiple ways to skin this cat.
Yeah, yeah. So so you've got the vulnerability information, and there's a bunch of places you can go for this. There's like CVE, there's MVD, there's GitHub, there's OSV from Google. Like even the Go project itself publishes vulnerabilities in the Go packages.
Mm-hmm.
The detail they provide is amazing. They even have like reachability analysis they include in their metadata. Like it's phenomenal what they've
Mm.
done. So good. But yeah, yeah. So you've got a vulnerability and you need to acquire information. Oh, I should clarify one more thing. VEX stands for Vulnerability Exchange. And the intent behind VEX is a way to convey, like, I am affected or I'm not affected by a certain thing. Because this is
Mm-hmm.
where, like, a good example is Go. Like, let's say you have a Go binary, but it doesn't include a certain aspect of a package where, let's say, like there's a /x/crypto is one of the libraries. It always has weird problems, right? Where there could be a vulnerability, and like actually this just happened. There's a vulnerability in the SSH component of X crypto for Go, but like no one's using that unless you're building like an SSH server, because it was
Yeah.
specifically focused on the SSH server aspect of that. So they include like that metadata. And so you could use Vex, for example, to say like this vulnerability, the CVE affects this package that, yes, I have included, but the code is not present in my thing. And so Vex has
Yeah.
these
That's
different
awesome.
states that's like code present but not used, code not present. I don't even remember what they all are. There's like 8 or 9 like possible states you can have where you can kind of justify why you're not vulnerable. And you can imagine this is super valuable, especially like in the space I live in, where you run these scans and this is unfortunate. Quite often a customer will like run a scan, and instead of like coming to me and saying, "Hey, I think these are all false positives. Like, what do you think?" They often go to the vendor and be like, "Hey, Red Hat, you've got all these vulnerabilities." And Red
Vulnerabilities.
Hat
Yeah.
like, "No, we don't." And actually, Red Hat publishes really good
Yeah.
vulnerability data, and they publish Vex data. I said this is one of those instances where by having good data, you actually can make your life a little easier in that
Yeah.
regard.
Yeah. This was a frustration for me as a Python developer, when earlier scanning tools would be like, "Hey, you're vulnerable," and I'm like, "Yeah, but I'm not calling the vulnerable function in that library."
Yeah.
Right. And it seems to me like this particular problem space has evolved and gotten better, which is encouraging.
It's getting better. I wouldn't say it's
Mm.
gotten better.
Okay.
We have an idea of where to go. But
Right.
now at the same time, like it should also be added that there are a lot of things that have terrible vulnerability information. Be it the vendor doesn't publish good information, be it it's like some random open source project that doesn't care because it's like one person and some, bug bounty got a hold of their stuff and published a bunch of things and they threw their
Yeah.
hands in the air, whatever. There's a million reasons you can have like just terrible vulnerability information. And that's one of our challenges in this space is how do we take some of this straw and spin it into gold to make it actually, useful? Because I mean, like from my perspective, every time you have a false positive or a false negative finding, like that's a bug, right? That's a
Yeah.
bug in your tool. It's not the vendor's fault. It's not the user's fault. Like it's the tool's fault. Fix your bugs.
Right. It's the false negative thing that concerns me more because not every vulnerability gets a CVE. And
Yes.
this is something that's super frustrating to me. I mean, we've been in these frustrating situations as Eclipsium. It actually is published on our blog, right? There was a vendor. We said, "Hey, there's a vulnerability." They said, "Well, in the next version, we just remove that software component and we're not going to issue a CVE because the vulnerability doesn't exist anymore." Like running under the assumption that everyone updates
Yeah.
all of their stuff as soon as there's a new release available. And we all know that's not true. And there's like a million other, I think Jericho had a great blog on just this subject of vulnerabilities that don't get a CVE and provided
Yeah.
several more examples. Go check out Jericho's blog. That article was, I was like reading it like, yep, seeing that. Yes. Right. And
I know.
this is frustrating. How do we do I mean, just identifying in your own software what has a CVE is one thing, but then the next step is how do we go deeper? How do we get better? And I agree. We still have work to do just to get to the point where we can identify known vulnerabilities that have CVEs in our own software. And that's a good step. Step 2 is what other exposures and vulnerabilities do I have that aren't covered by CVE?
Yeah. I mean, so look, this is one of the many complaints many of us have about the CVE program is I think there's two sides to this. There's the angle of the CVE program is not as automated as it should be, and there's definitely like very human limits to what's going on. So adding like potentially thousands or tens of thousands of vulnerabilities in a year would crush the program. I mean, the Linux kernel showed up last year
Yeah.
and they were crushing a lot of vulnerability groups because and the funny thing is they are publishing some of the most detailed metadata rich CVEs like ever created.
This is after they became a CNA.
Right. Yeah. Before that, their vulnerabilities were terrible because it was like
Yes.
random companies doing whatever. But since like the work Greg KH has been doing is like phenomenal, and there's so much data, but they're crushing people because people just can't keep up. And I know Greg's talking point is just upgrade to the latest kernel because we don't break things right, like that's the kernel thing. And for the most part, he's correct.
Yeah, I agree.
It's shockingly good. I mean, a lot of Android devices, for example, have just started taking the latest long-term kernel, and it just works.
Thank God for that. And Fedora and Ubuntu have also pushed the envelope, including much newer kernels in their recent releases, which is nice to see, which is encouraging now for the embedded space to also catch up and go, the latest kernel's where it's at.
Well, let's hope so.
We can only hope.
So anyway, we've got that side, right? There's the, I guess, producer side, which is basically running at 110% all the time. Then you have the consumer side where you've got the people on the receiving end of the vulnerability data, on the scan reports, all of this, and they're all running at 110%, and none of them can keep up with the current load they have. And so like Jericho is correct. There are tons of things that don't get CVEs, but the problem is no one cares because like anyone in this space, if you say I could add 500,000 CVEs a year, they're going to like shoot you and go bury you in the yard because like they can't handle that load at all. And this is one of our challenges is across the board, across the whole vulnerability universe, we need a ton more automation than we have. Because like the reality is most of these CVEs, a human should never look at or know the name of or care. Because it should just be like the data flows in, it flows through the system. And then on the other end, you might have, Dependabot or whatever tooling is like, yep, great, upgrade that package, problem solved, nothing to see here, folks. Mm-hmm. And we just don't have that today. And that dream is, we do not have a path to that right now.
Well, because the validation is a problem, and it has been. I mean, we've seen several. The poor Daniel at Curl. You interviewed Daniel from Curl, right? Yeah. He's unfortunately for Daniel, our shining example of where this goes sideways, right? And CVEs need to be added, but they're not really vulnerabilities. That's a problem, right?
Yeah.
But how do you validate that? I think at one time, actually, I know at one time because I remember this. There used to be CVE candidates, and there was like people who voted on them.
I know.
And to think about that today is ludicrous because we would never get anything done in CVE.
Yeah, but I mean, back then, like that, early 2000s, because CVE started in 1999, and you're talking about, a couple hundred a year, maybe. And last year we had 40,000 CVEs, and this year, thanks to the Linux kernel, like we're going to blow that out of the water.
Oh, yeah. Well, I think there's lots of things that skew the data.
Well, there's two things that skew the data. There are the Linux kernel is a huge one. And I've got a marvelous graph where just one day they filed 1,000 CVEs. Yeah. Like it was so good. But then the second is actually WordPress plugins. Bad. Because there are a bunch of like WordPress bug bounty type companies where they're
CNAs.
They're CNAs.
Their own. Yeah, I put that in one of my presentations a couple of years ago. Yeah.
Yeah, they're the source of virtually all of the growth right now today in the vulnerability universe. But that like their business model is telling companies, if you use our scanners, we'll pick up all the problems and all your WordPress stuff, and then we'll upgrade it for you and whatever.
Yeah.
Versus if you don't, then you're kind of in trouble. And so part of the way they kind of encourage their business along is they file a lot of CVEs in all of the WordPress plugins.
I think that's what Jericho was hinting at too, is like, how do we get down to the vulnerabilities that matter? Because if there's a vulnerability in some obscure WordPress plugin that's used by 10 people, no one really cares.
Yeah.
But he also gave an example like AIX has vulnerabilities that haven't been filed. I'm like, well, that's way more problematic than a WordPress plugin with 10 users.
Well, but okay. So I have two sides to this conversation. There is the argument of we need the things that matter. And I agree with that. Mm-hmm. There are always things that are more important than other things for a variety of reasons, right? Like Log4Shell is a great example. Log4Shell was a big deal that affected a lot of people, and it was a mess. And then, yes, there is a WordPress plugin with 10 users, but to those 10 users, that matters, right? So it's easy to discount it from like the large population perspective. But if I am one of those 10, yes, I care, right? I don't want to get popped because I'm running this weird, obscure plugin. But again, this is where if we have this automation and we have the ability for this stuff to all just kind of magically go through the system, it doesn't matter if it's 10 people. Like we don't care. You'll never see it. There's not a huge load being put on anybody. It's just that everything is working as expected. And one of those 10 people are going to get the alerts they need. They're going to get the upgrades they need. Everyone's happy, right? But we don't have that today. And that's why we often have these arguments of, oh, let's just find the things that matter. When the real problem isn't finding the things that matter. The problem is like you have to automate this crap because there's just too much of it.
And it's hard to automate and sift through things that matter because it depends on your perspective as well.
Right. Yes, 100%.
Right? Those 10 people using that WordPress plugin is probably really important to them.
Yeah. Oh yeah. Yeah, for sure. I mean, even like I think about like the embedded universe sometimes, right? Where it's easy to say, okay, so we've got a machine, there's only 7 in the world. And so it has a vulnerability. It's only 7 machines. Who cares? Except, oh, those 7 machines are making all of our microprocessors, right? Like, so like,
Yeah.
that kind of matters, or maybe that machine's in space now, right?
Yeah.
Like there's all these weird use cases that it's like, yes, it is a very small amount, but the potential impact from that small amount could be very, very, very large.
Is the next level of diligence just looking at the source code for vulnerabilities and looking at the patches and not getting too hung up on is it a vulnerability, but making sure you're on the latest version? But also the other side is looking at your own source code for vulnerabilities independent of CVEs.
I mean, yeah, I think that's part of it for sure. And there's better tools than we've ever seen before. I mean, the tools they still aren't amazing. There's still a lot of false positives when you run a lot of these tools. I mean, they are better now than they were, and they will continue to get better. I have no doubt.
Is AI promising in your mind, Josh, to help us
man,
identify vulnerabilities in software? There's been a lot of projects that have looked at that, right? With not great success, I will say, but I think it's promising is where I put it in my mind. Curious to get your take.
it has potential. I agree. I mean, it amuses me when like Daniel Stenberg from Curl, he always posts these like slop vulnerability reports he gets.
Yeah, and
I feel
AI,
they're really funny. I feel bad for him because he had to like deal with it. But then as a viewer, they amuse me to no end.
Right.
But I feel like I think there is potential in a lot of this technology, and I think there is some interesting work happening here. There's actually NVIDIA has a really cool tool. I think they named it Garrick after the Star Trek character from Deep Space Nine, the Taylor/Spy. And what this does is it will look at like a vulnerability report, and SIFT is in this mix somewhere, which is why I actually know all about it because I was, I have a personal interest, but it basically like generates SBOMs. It scans the SBOMs for vulnerabilities, and then it uses an LLM to look at the vulnerability descriptions, and it has some context for what you're doing with it. So an example being, if I have a web server, it knows that any of the vulnerabilities that are like vaguely web related, like those probably need to come up to the top of the list versus saying like this is some backend system that has no internet access and it's not doing anything. Like, all right, we can probably say that there's not a lot that's going to matter here. And I feel like there's some interesting things happening there, and I'm hopeful we can turn some of it into something useful. The thing that I think though, the thing that really annoys me to no end is there's so often you've got like your AI fanboys that you're like, oh, I have this problem. Like, oh, AI can do that. It's like, then do it. Oh no, I won't. Someone else will do it. It's like, no, they won't because it can't.
Yeah.
And I think that's one of the problems. It's like, this is a tool that I feel like has some potential, but it's also being crapped on by a lot of people because like, the annoying fanboys are ruining it for the rest of us.
Yes. Yeah. The over enthusiastic over usage of AI is hurting us.
It's kind of like when we were young and Linux fanboys, Paul. Everyone hated Linux because like we once shut up about it.
Right.
Yes, exactly that.
That's anyway. Awesome. So tell me a little more about SIFT and GRIPE and how people are using that today, Josh.
Yeah. So I mean, it kind of depends what you want to do. Like SIFT is an easy tool where a lot of projects are just using this to generate software bill of materials. You can put it like in your GitHub action. It'll spit out a software bill of materials for your project, and then you ferret it away as one of your release.
But not for C++ so much.
It sucks at C. Yeah, I'm not going to lie.
Because that was my experience. I communicate with you directly on that. And the ESP32 project. And I'm like, I want to know where my supply chain vulnerabilities are. And it's hard.
Like if you're doing Python or Node or Rust or Go or basically any of like the big languages we'll say right now, does a great job. Gotcha. It's going to tell you exactly what you have. You're probably going to see some things you didn't even know. And then my first bit of advice is just save these things. And you don't even necessarily have to have a plan, just keep them around. And the reason they're actually valuable is because someday you might have to ask the question, have I ever run this piece of software? And this actually happened during Log4Shell.
Yeah.
Where there were like, Anchor had some customers that had been using our tools for many, many years. Log4Shell happens. They're like, I need to know where Log4j is or ever has been in my infrastructure. We're like, here, run this query on the database. Like 5 minutes later, like, great, we have a list of all the things we need to go investigate now. Thank you very much. Versus
and that's because you can incorporate SIFT as a library, so it's just automatically generating an SBOM for your software. Is that true?
well, it's not that it's a library. You just put it in your build pipelines and stuff.
In your build. Okay.
Yeah, right. So it's just automatically being created, and just that part is like super valuable. And they're small. They're just JSON documents, right? Like if there's one thing we're really good at as a technical group of people is storing JSON documents.
Yeah, we're all hoarders.
We figured that one out.
Sure. And you can do this for your containers too. If you put in your build process, it'll generate an SBOM for your containers.
Yeah, for sure. And in fact, Anchor Enterprise and SIFT and GRIPE, like their start was in container scanning.
Okay.
Like that's where their inception existed. And because, I mean, a long time ago, knowing what was in a container was really hard to do. And so that was kind of their use case. It's ironic that they started with source code and people were like, whatever, we don't care. We want to know what's in our containers. They pivot to containers, and now we're pivoting back into source code because that's what everyone's asking questions about now.
So SIFT is generate an SBOM essentially. So what is GRIPE?
And then GRIPE is a vulnerability scanner. And so GRIPE uses SIFT as a library. So you can just point GRIPE at like a container or a directory or whatever, and it'll figure out what's in it. And then it'll use a database of vulnerabilities that, and this is all like open source. So if you're interested, you can find all how the database is made and all that stuff. And then it will just tell you the vulnerabilities in your packages, or it'll suss out like binaries on the system or kind of whatever. It has a large number of supported things, we'll say. It's not the universe, but it's a lot of stuff.
And it's open source, so hopefully people are contributing to it.
They are. They are actually.
Good.
Which is really cool because we just got a pull request for something called like Minim OS this morning for GRIPE. I'm like, I have absolutely no idea what this is, but I love the fact
that's great
that like someone contributed this. You know?
That's super
so cool.
That's super great.
So good. So
what about Erlang? Does it support Erlang?
Yes.
It does.
No, it does. We had someone ask about that. Yeah.
Yeah, because we just had that vulnerability in Erlang that was in the SSH. Is that a library in Erlang? I didn't dig into like the detail. I listened to a podcast about someone that does open source Erlang stuff, and I'm like, you got to explain it. I'm like, oh, I get it, like the history behind it and stuff. I think it was Floss Weekly. It was a great episode, and this vulnerability came about, and it's your typical vulnerability that lives in both your world and my world, right?
Yeah.
Erlang's used on a lot of embedded devices for telecom. That's, I believe, where it got its start, but it's also used in things like WhatsApp and modern applications, which I didn't know until I was like researching it.
Like the people who like Erlang, man, they really like Erlang.
Oh yeah. But
anyway,
some of the comments, like, if you need a device that's like underneath a foundation, you build it in Erlang because it'll just run.
Yeah,
and it's a pretty bold statement.
I mean, from what I've seen, I won't argue with that. Like it seems very good.
Yeah. But suffers from the same problems we've talked about that needs to have that supply chain security and analysis done with it.
For sure. But now, okay, back to SIFT and GRIPE. So the beauty, the best part about GRIPE though, is you could give it an SBOM. And so now we've got our huge repository of stored SBOMs. And so if GRIPE scans, say, a container, it might take half a second, it might take a second, it might take 90 seconds. It just depends how much stuff there is and how big it is. But scanning an SBOM, we can scan an SBOM in like milliseconds.
Yeah, because this is a file that contains the message.
Right.
Yeah.
And so now what happens is instead of scanning,
SIFT doesn't have to generate that SBOM, Josh. Right.
You do it once.
Any SBOM.
Yes, that's
however you generate it.
Well, okay. So I'll put an asterisk here. Is GRIPE can scan other SBOM formats. There's like SPDX and CycloneDX, and GRIPE SIFT has a format we call SIFT JSON that it spits out. That is not meant to be like a format anyone uses. It only exists so we can spit out SPDX and CycloneDX formats because, of course, they are incompatible formats and you can't convert from one to the other. Why would you do that?
We had a standard. Right? We didn't like that standard, so we created a new standard. Right? Yeah, I get it.
and that's a funny thing because it's like we're explicitly not creating a third standard. Like that is not the goal. Do not use this. But anyway, yes, GRIPE can scan SPDX and CycloneDX, but it depends how it was generated. I mean, this is like any good standard, right? Is there are many ways to conform to the standard, but still being completely useless in reality. And so maybe that's my answer. It depends, right?
Right.
Good answer. But anyway,
because adherence to the standard is left up to the developer. Yeah, that's an age-old problem. Sure.
And the standards are getting better about reining some of this in. Where like SPDX 3.0 just came out, and it's much stricter Then I think it's 2.3 was the old one. I can't even remember anymore what the old version was. But anyway, so like, yeah, that's the beauty of the SBOM. So it's like, once you have them, you can do all this crazy stuff with them where you can scan them for vulnerabilities. You can look at, like, one of the things we're working on right now at work is we have all these file checksums in an SBOM. Well, why aren't we comparing that to like known malware lists, So we can say, like, now instead of, my malware scanner taking half an hour to scan my system, I can scan it in, 100 milliseconds because I'm just checking against this huge database of checksums. And so there's some really fun things that are starting to come out of this. Or like license compliance. You capture open source license information in an SBOM. Right. So now we can start saying, like, when the lawyers say, do we have any GPL? You could be like, let me look. Half a second later, you can say, no, we don't. So
I
there's
some cool malware
stuff.
Scanner component, because I think we need to get fancy with it to detect malware, but also the level the playing field. If there's known malware, we have known ways to find that.
Yeah.
Interface with virus total. If I have hashes, I can compare them. It kind of comes back to, I've got software has vulnerabilities, they have CVEs. That's like the table stakes, right, for both of those problems, for sure.
Yep. And that's the easy thing, right? Like, vulnerabilities are kind of the very obvious first thing we're doing, but it amuses me that we're taking this seemingly boring thing, like a software bill of materials sounds like the most boring thing you could possibly, care about. But there's all these other use cases that are starting to come out of the woodwork with it, which is great. Because as things like the CRA in Europe demand these things, we're seeing, like, in the US right now, the FDA, I think, is the only organization demanding SBOMs in the US federal government. But there's a lot of work going on where there's a push in this direction. And so
it's a great way to close too, right? Talked about great open source solutions for identifying what's in your software, for identifying vulnerabilities that you can put in your build process. These are the types of things we need to be encouraging all the vendors that are making software and in the hardware that it runs, right, to do that. That's important.
Yeah. Well, one of my favorites is, like, if you ask someone for an SBOM and they won't give it to you, like, why not?
Yeah. I mean, there's a lot of, we're talking about the reasons, right? But it's, what are they hiding is my first question.
Well, that's the thing. Are they incompetent? Are they hiding something? Like, do they not know what you're like? There's none of them are good reasons.
Yes. For the consumer and the, whoever's buying it, not good reasons, right?
Yeah, for sure. Well,
so, awesome.
I don't know. It's exciting.
Josh, anything that you want to plug and as we close the show?
Oh, man. I can't. I guess, well, I don't know when this will go onto the podcast feed, but I know it's going live right now. So we've got Paul is on open source security. I'm almost done editing the episode right now.
Sweet.
And we talk about all the embedded stuff. That's a lot of fun. But I got this opensourcesecurity.io is that show. I've got Hacker History, just hackerhistory.com. That one's a ton of fun. I'm always looking for, like, crazy niche open source security things. Like, if anyone wants to be a guest on open source security, let me know. If you're an old school hacker looking to tell stories, like, hit me up for that one too. Like, Hacker History is so much fun. I love that show so much.
Awesome.
But, yeah.
Well, Josh, it's always a pleasure to do podcasts with you. So
it's a treat. I love it, man.
Awesome. Thanks so much, Josh. Thanks everyone for listening and watching to this edition of Below the Surface. We'll see you next time.